Hello, my name is Ty Bugden, and this is my final submission for the open-ended project, for which I created a coin weighing scale, which would take in the input, which is how many actual coins you put on the scale. And when it reaches a certain value, it will turn on this LED. I also use this button to check to make sure that the LED works in the code in the loop. Otherwise, I'd be testing pretty much blank stuff. As you can see, I built my scale here using a 5 kilogram load cell and wired it as such. I have used a Wheatstone bridge configuration here. However, the only issue with using this Wheatstone bridge was that I didn't have the proper resistors. So what I've done here is I've created these large loops of series of different resistors. The resistances are, I believe it's 10, 20, 100, and 220 ohms to create a 350 ohm resistor. That matches the resistance of the strain gauges, which are top and bottom of the strain gauge, not the strain gauge, the load cell here. I have the limit, which would normally turn on the light, the LED, set to it's 20 coins. I have a scale loaded with 80 coins, not 80 coins, $8 worth of coins, which is 32 coins. So at this amount of coins, this should be turning on the light, but it's not, and I believe it's just an issue with the coding that I couldn't figure out. However, I did get it to turn on with the button, so that just points more fingers towards the coding. Some issues with the actual data acquisition that I found was, depending on where the position of the coins are, they produce a different torque on the load cell, which creates a different amount of strain on the piece of metal, piece of aluminum that's here, where the strain gauge is taking data from. So I tried to place them as close to the same position as possible. I did have them all stacked up originally, and that seemed to mitigate the differences that I got. So once I had some data to take, in order to make sure that I'm taking these measurements accurately, I had to calibrate the scale here according to some data that I had taken. See here, I have the measured data and the actual data, the measured data, I guess they should be flipped. The measured data was taken from known weights of a quarter, which is 5.67 grams according to the US Mint website. And then I used that data against what was measured, which is taken as the actual data here. Like I said, they should probably be flipped in order to create this regression curve with a slope of 0.727 and a R-squared value of 38.7. The 38.7, I believe, is because of the weight of the plexiglass here that I've used, as well as the screws that I've used to attach the plexiglass to the load cell. This test apparatus was unsuccessful on the fact that I could not get it to visualize the scale reaching a certain number of coins using the LED. However, I do think with a bit more work on some code and a little bit more understanding of how to code in Arduino, since prior to this class I had never coded in any language before, I think with some prior knowledge and a little more adjustments, the project could become successful and even advanced to weigh other coins such as pennies, dimes, and nickels, or even $50. I do not think this would work for dollar bills, as they all weigh about the same. Or I should say notes, tender notes, not just dollar bills. So yeah, thank you very much.